will set and did set. Okay, so these are little pieces of code inside the will set and did set. They get called when that property gets set by anybody. So it's called a property observer because I'm observing, with this code, I'm observing this thing is being set. And the will set is called right before the property's value gets set, and the did set right after. And inside the will set, you got this special variable called new value, which is going to be the new value that's going to be set. And then inside did set, you've got this special thing called old value, which is the old value. Okay? Now, you use this in really kind of these two cases. One is you have a stored property in yourself, in your class, and whenever someone sets it, you want to kind of notice and do something, okay? And the other one is you inherit some property, and you don't necessarily do anything with that property directly, but you want to know when that gets changed by anybody, okay? So you can even do will set and did set on properties you inherit from somebody, from your superclass, okay? Now, what kind of things would we do in here? Well, one extremely common thing to do in iOS is to update the user interface. So you have some view controller, let's say, or you have a view, and you change some property in it, and changing that property means the UI would change. So in the did set, you'll go update the user interface. Does that make sense? Okay, so the observers are really cool. They're a really good way to kind of keep track of what's going on and keep things in sync. All right, lazy initialization. So a lazy property, if you put lazy in front of a property declaration, it means it does not get initialized until someone accesses it. And that's true whether it's initialized with equals something. So that equals something will not happen until someone actually accesses that property. Or you can actually initialize it by putting a closure there, put parentheses after it, and it will execute that closure. And that will initialize the property. But that closure won't get executed until someone tries to get it. Okay? And then you can even, in a lazy property, you could call a method to initialize it because normally you wouldn't be able to do this if you didn't say lazy because you can't call any methods in your class until you're fully initialized. So there's kind of a catch-22 there. But in this case, since you can't call any methods until you're initialized, by the time someone tries to get this property, you'd be fully initialized. So you can call methods. So do you see the advantage of lazy there? Okay. This lazy thing still satisfies the rule that you must initialize all of your properties. Okay. Even though it doesn't actually initialize it until someone accesses it, it still satisfies that rule. Unfortunately, only vars can be lazily initialized. Things that are let, if you had constants in your class, those would have to be initialized in your initializers. You can't initialize them lazily. Only vars, not lets. This can be used to get around some kind of tricky initialization dependencies. Because of that rule that everything has to be initialized before you can do anything, sometimes you can get into fights with your superclass, for example, about when something's going to be initialized, and you need your superclass to do something before you can do something, but it needs you to do something before they can do something, so you're kind of, we're stuck. And what you can do is one or the other of you make one of the things that depends on their lazy. Okay, and then as soon as somebody wants it, it'll get initialized, and off we go. Okay, any questions about lazy? Pretty cool feature, right? And it's exactly what it sounds like. It just lazily waits to initialize until someone wants this property. Okay, so now let's talk about initialization. So I need a drink before we do initialization because it's complicated. Hopefully, this is not, just taking my voice here. Okay, init. All right, so when do you need an init method? Well, you know what? You actually don't need an init method that often. Okay, we should have the init method in the calculator brain. Made sense there. We needed it there. But you don't need that often because a lot of your variables and constants in your class or struct are set with equals. So you don't need them. Or maybe the properties are optionals. And so they can just start out nil and you set them later, okay, like the outlets in a storyboard. Or you can actually initialize by using a closure. Okay, as I showed on the previous thing, that lazy thing, that you can do that for non-lazies, put the closure thing there and execute it. It'll get executed right away, and nothing inside that closure could refer to any other instance variables, of course, because it would be executing before the initialization was done, but still, you can calculate some things to assign things in a closure by executing a closure. Or you could just use the lazy mechanism and then to avoid needing an init. So there's a lot of ways to avoid init. But if you do need an init, then how do we do init? Because init has some kind of interesting interdependencies. It's not as straightforward as you might think. Now, you get some free inits, okay, inits that get done for you. One is that if all the properties in a class, in a base class, not something that has no superclass like calculator brain, if they all have defaults, then you'll get an init with no arguments for free. So if we hadn't implemented calculator brain's init, of course we still could have said, you know, brain equals calculator brain parentheses. That's because we got a free init in calculator brain because we initialized all our defaults using equals something. Okay, so that's one way to get an init. A struct, not a class, but a struct, it will get a default one that has all the properties as arguments only if you have no initializers. So if you had a struct and you gave it no initializers, you would get one for free, which would be init, where all the arguments match all of the vars you have, all the vars and lets. Okay, so like here I got a struct. It has two properties there, x and y, and you can see that I got this init. X takes an int and a y string for free. I didn't have to implement that at all. It just came for free. And so people can call that. They can initialize my struct by saying my struct, open parentheses, and provide the x and the y. Okay? All right. So what can you do inside of init? Okay, we saw what we did in calculator brain. We initialized some stuff. But what can you do? Well, you can set any properties value in there. You can even set properties that have default values. So even if you have a property and you said equals 12, in your init, you could reset that thing to something else if you wanted to, if you changed your mind in init. Okay? You could do that. You can also set constant properties. So if you have a struct or a class and it has let x colon string, you can set that in your init. Even though it's a let, it's got to get set sometime. In your init is when you can set it. You can also say equals something, but you could also set it in your init. Okay? So people sometimes don't realize, they're like, oh, I can have lets in my class. I can have, like, you know, constants for my class that are created at initialization and stay the same for the whole lifetime of my instance. And absolutely you can. And you initialize them in your init. Okay? That's actually good practice if you have something that's, you know, constant like that. You can call other init methods in your own class or struct using self.init. Okay? Self.init, you can call the other ones, with the ones that have different arguments. Okay? So that sounds good. And of course, in a class, you can call super.init. Call your superclasses initializers with their arguments, whatever they might be. However, big old humongous however on this one, there are a lot of rules for calling other inits, especially in classes. Okay, in structs, it's not a big deal, but in classes, there's a lot of rules, and we're going to take 2 slides here to go through these rules briefly. All right, so as part of these rules, what are you required to do inside of init? What is mandatory for you to do? Well, as you know, you have to have initialized all the properties in your entire class. You cannot start a class off with no values. And remember, optionals, nil is a value for an optional, so if an optional is nil, it is set, so everything's fine there. There are 2 types of inits in a class, not in a struct, but in a class. One is called a convenience init, and then there's all the other kinds. Those are called designated initializers. So by default, an initializer is called a designated initializer, but there's also these things called convenience initializers. And we make this distinction because there's a little bit different rules about them, so let's talk about that. A designated initializer, one that doesn't say convenience in the front of it, it has to and can only call a designated initializer in its superclass. This is a very important rule. Okay, if you have a designated initializer doesn't have the word convenience in front of it, it can't call another init in your class. it has to call a superclass as init, and it has to be a designated initializer, not a convenience initializer in the superclass. Okay? Understand that rule number 1? As for designated initializer. This is all, by the way, in the documentation. It's very elaborately drawn out with pictures and all that. I'm just trying to summarize it here. Okay? Hopefully you've read that already, and this is review, but if not, hopefully understanding a little bit of what I'm saying to now, when you read it, you'll say, oh yeah, I get it. Okay, so that's the rule for designated initializer. You have to initialize all of your own properties before you call your superclass's initializer. Okay, this is for designated initializers only because they're the ones who call their superclasses initializer. So you have to be done with your own properties before you call your superclasses. This one will trip you up often. Okay? You also have to call your superclasses init before you assign a value to any property you inherit from your superclass. In other words, you have to let your superclass initialize its properties before you can start setting them. So you get those 3 rules. Okay, that has to do with your it has to do with designated initializers and calling super. All right, now a convenience initializer has different rules. Okay, first of all, a convenience initializer must and can only call a designated initializer in its own class. Convenience initializer cannot call super init of any kind, and it can't call, and it must call a designated initializer. Now, it can call that designated initializer indirectly through another convenience initializer. Okay, so one convenience initializer could call self another convenience initializer, which could call a designated initializer, but eventually a designated initializer must be called. Okay. A convenience initializer must call that designated initializer, directly or indirectly, before it can touch any values, obviously. Okay? You have to kind of get your object primarily initialized before you can have the convenience initializer start hacking at properties. The calling of other inits, whether you're a convenience guy calling your designator, or whether you're designated calling up to your super's designator, has to be complete before you can start accessing your properties and methods. In other words, the class has to be initialized before you can start calling methods and properties. Okay? That's why we have to use lazy if we want a property to set its value to be calling a method, because we can't do it non-lazily because we wouldn't be initialized at that time. We'd still be in the process of initializing. It's kind of a 2-phase initialization. You get fully initialized, now you can go do that. Okay, so these are the rules. Question?
Is there a way to set constant then by like calling a method? Like,
so the question is there a way to set a constant by calling a method or something like that? And the answer is no. Okay, you can only set constants either setting them equals something or in your initializers. Unfortunately, later you can't do it. Okay, let's talk about inheriting init. Okay, because this is complicated as well. So here are the rules for inheriting init. If you do not implement any designated initializers in your class, then you will inherit all of your superclasses' designated initializers. Otherwise, you will inherit none of your superclasses' designated initializers. Okay? It's all or nothing on designated initializers. If you override all of your superclasses' designated inits, okay? So your superclass has 3 designated initializers with different arguments. If you override all of them, then you will inherit all of your superclasses' convenience initializers. Also, if you implement none of them, because you'll essentially inherit all the designateds and all the convenience in that case. Okay? So that's the inheritance rule. And this trips people up too. They're like, oh yeah, I implemented that one initializer, but how come the other initializer doesn't work? Well, because once you implement one designated initializer, you don't inherit the rest of them. Okay? So it's all or nothing on designateds. On convenience, it's kind of all or nothing too, because you have to implement or not implement all of the designateds to get the conveniences. Any init that you inherit by these rules that I just said count for all the rules on the previous slide. Now, I'm not going to go back to the previous slide and go through them all, but you can satisfy a lot of the requirements in the previous slide by just inheriting your initializers. Okay? But you can only inherit them in these kind of restricted ways, but once you do, you can satisfy a lot of those previous rules. It is possible to have what's called a required init. You just put required on it. And if you put required, it means that subclasses must implement it. It is required. Now, they can inherit it by the rules above. In other words, if they don't implement any designated initializers, they'll inherit the required initializer. That's good. But if you implement any of the designated initializers, you must implement the required ones. Okay? Finally, there's failable initializers. Okay? So some initializers are allowed to fail and return nil. Okay? You designate them by putting question mark after the init like this right here. Okay? Now this is pretty uncommon. Okay? You don't see this very often. And the documentation, last I checked, doesn't really show this very well. It doesn't put the question mark in there. I think it's just a documentation generation problem. It will say in the comment for the init, this can return nil if it fails, but it doesn't seem to put the question mark on there. But that's okay, because when you start using it, you're going to call this initializer, and the thing's going to come back, and you're going to try and send messages to it, and it's going to say, this is an optional, does not respond to the method. And you're like, what? It's an optional? And then you're going to know, oh, the initializer was failable. So let's look at an example of this. So UI image, okay, it's a class in UIKit. And it returns an image. And you can ask for an image by its name. But of course, that image named that might not be anywhere in your project. So this thing can return nil. So in this case right here, image equals UI image named foo. Image is an optional UI image. Even though I'm calling an initializer there, right? UI image is initializer. It could be changed. So usually what we do in this case is we use if let. Right? If we can let the image equal the image named foo, then we'll do what we want. Otherwise, we couldn't find it, so we'll do whatever we do in that case. Okay? So watch out for those. There's very few of them, a few dozen at the most. Yeah?
Does this replace like try catch?
So the question is, does this replace try catch? We're not even going to talk about try catch in this class. Okay? That's how rare it is. You really don't even use try catch in Swift. You know, things are, optionals make a lot of try-catch stuff just not necessary. Try-catch, for those of you who don't know, is you can raise exceptions in your program and they can percolate up the call stack and someone tries to catch them and handle them, okay? And that programming methodology is not one that's really something we use very much in iOS, okay? In Objective-C, maybe it was used even a little more, I'm not even sure about that, but certainly in Swift, we're not going to be using that. I'm not even going to show it to you in this class, that's how unnecessary it is to know that. Okay, so let's talk about creating objects then. You know to do it by putting the type and then parentheses and then the arguments to the initializer. Okay, it's completely obvious there. You notice you don't always create objects by doing that. Sometimes you will ask a class method or a type method to do it. So here's one, button with type. You see that's being sent to UI button, the type. Right? It's not being sent to a UI button. It is being sent to the type, like we talked about before. And so sometimes you'll be creating things that way. Very rarely. Apple's been moving away from that model and more towards just using initializers and creating things. But there's some that do that. Like remember UI image on the previous page, that wasn't UI image.image named. That's kind of how it used to be in Apple. Now it's UI image, parentheses, whatever, call the constructor. Sometimes other objects will obviously create objects for you. So like here's a really cool method in string called join. Okay, join takes an array of strings and it will separate them by whatever string you send join to. So comma dot join of an array will give you a comma separated string, a string with the things in the array comma separated. And that's obviously creating a new array. So this is kind of completely obvious, but yes, some methods return objects to you that were created. Okay, so now let's talk about any object. This was brought up earlier. Any object is kind of a, okay, for the purposes of what you know so far, you can think of it as a type. Okay, it's not really a type, but you can think of it as type, like double or array or whatever. And it's used primarily for compatibility with existing Objective-C APIs in iOS. Okay, you're really not going to use any object to build your own data structures very much. I suppose you could, but it'd kind of be, again, kind of anti-Swift. Swift is very much into strong typing and type inference and all that. So you could, but I'm only going to talk about it in the context here of using it as this compatibility thing. All right, so what is any object, okay? And where will you see it? So any object means a pointer to an object, meaning an instance of a class, okay, that you don't know what the class is. So it's just kind of pointer to unknown class, okay, which seems kind of weird, and it is kind of weird. So we're going to have to play around to be able to use it, but that's what it is. And where will you see this in iOS? Sometimes you'll see properties that are any object, like there's a property on storyboard segues, which we're going to talk about next week, called destination view controller. Instead of being a UI view controller, it's a type, it's any object, okay, for historical reasons, really. And similarly, in UI view controller, there's a property called toolbar items, and it returns an array of any object, okay? So basically, these properties are giving you back things you don't even know what they are, okay? You'll also see them as arguments to functions. Like here's a UI view controller method prepare for segue. It takes a normal argument there, segue, but then it also takes a sender, which can be any object. Now in that case, it kind of makes sense because it really could be any object in that case, because whatever's causing this segue to happen in your user interface could be any object, so it would make some sense. But there's add constraints, okay, which is another UI view controller thing. And you add the constraints, you think that would be array of whatever class constraints are. I haven't taught you about this, but these are the constraints that do all our UI shifting. But again, for historical reasons, it's an array of any object. And even in append digit in calculator, okay, remember when we control dragged the button to make append digit? And I made a big deal of saying, change that from any object to UI button, okay? Well, if you hadn't changed it, then you could have ended up with append digit sender any object, okay? It also can even be the return type for functions. Like that button with type I talked about a few slides ago, it actually returns any object. It doesn't return a UI button. You'd think it would, but it doesn't. It returns any object. Okay, so this, you're probably like, what the heck is going on? Why would we be passing around these pointers? We don't even know what these things are, okay? Well, we'll talk a little bit why we do it, but let's talk first about how we use it, because it's this pointer to unknown object, so I can't really send any messages to it because I don't even know what it is, okay? And so to use it, we convert it to a type we do know. Okay, that's the only way we're really going to use any object, is to convert it to some class that we do know, right? And we do that with by creating a new variable. So we've got some any object. It was an argument to a method, or it's a local variable, or something like that, and we want to convert it. So we're going to create a new variable of the type we want to convert it to. Okay, and we're going to assign this new variable to be equal to that any object thing converted. Now, of course, we have to convert it to a compatible type. It actually has to actually be one of those things. So if we got the UI button back from button type and it comes back as any object, we can convert it to UI button because it is a UI button. Okay, but we can't convert it to a UI label. It's not a UI label, so that would crash our program actually. So how do we do that conversion? Yes, so that would crash our program if we do that. How do we do that conversion safely so we're not crashing our program all the time? So there's two ways, and we call this casting, okay? You know what type casting is. We're essentially casting the type from any object to something else. And we can typecast forcibly using the as keyword, as. Okay, Swift, as usual, very succinct. And so I'm going to use that destination view controller thing as an example. So I've got this property, destination view controller. It's an any object. And I know it's a view controller, and I think it should be a calculator view controller. So I'm going to be using in my examples calculator view controller. Imagine we had called our calculator view controller instead of view controller. I'm doing that in the examples because it's just going to make more sense, okay? So I want to talk to this destination view controller, which is any object, and I know that it's a calculator view controller. And if it's not a calculator view controller, my program should probably crash because in the context I'm using it, I want it to be that. Okay, so I can just say let calc VC equals calculator view controller as calculator view controller, and now calc VC, this new constant, its type is not any object, its type is calculator view controller. And so now I've gotten hold of that any object in a way I can actually do things with it, and I can send messages, calculator view control messages to calc VC. Now, you can protect against crashing if you're not sure whether that destination view controller is a calculator view controller, but you're hoping it is, okay? You can use as question mark. And as question mark returns an optional. Same as, right? As returns that any object thing cast to be a different class. As question mark does the same thing, but it's an optional version of that. So we can return nil if that any object, destination view controller, cannot be turned into a calculator view controller because it's not a calculator view controller, it's some other kind of view controller or something else, all right? And so you can say if let calc VC equals destination view controller as calculator view controller, and then inside there you've got calc VC set, and it's, you know that it's a calculator view controller, and any object is now in your past, okay? Make sense? So we get as and as question mark. You can also check beforehand if you just want to see, is this a calculator view controller? You can say is. So you can say if destination view controller is a calculator view controller, then I'll go ahead and then I can do the as, for example. But usually we use the as question mark, you know, check it and convert it all in one go. Okay? So that's how we're going to use an any object. We're going to have to cast it with as into something else. Question?
Is there a method which tells you what type it is? Because if it's able to check if it's not or if it is, it does know it under the code, right?
Yeah, so the question is there a way to kind of ask it what the type is and get the answer back in some way? And the answer is, for the purposes of where you are, no, okay? You don't do that. You ask it for certain, whether it can be a certain thing. You don't ask it, what are you? And then try and figure it out from there. We're not gonna use that paradigm. Okay, let's talk about arrays of any object. Because sometimes you're going to get an array of any objects back, like that constraints one I was talking about, where it's going to be an array of constraints that are going to be any object, but I know they're going to be NS layout constraints, but they're going to be an array. So you can do some interesting things with casting there. So let's use the toolbar items one. So that toolbar items, that's a property in UI view controller, and it returns an array that's going to have UI bar button items in it, but for historical reasons, it returns the square bracket of any object. So I can say for item in toolbar items, then item is going to be in any object. So I'm enumerating those any object, and I'm actually having my variable item be any object. But then inside, I'm saying if I can let the toolbar item equal, be a UI bar button item, then I'm good to go. So you see how I'm enumerating this array of any objects, and then inside I'm doing the as question mark. But I can do it another way too, okay? Which is I can say for toolbar item in toolbar items as an array of UI bar button item. In other words, I can cast the entire array. If I know that that array of any object is really an array of UI bar button item, I can just cast it. Now this one, you can't do question mark because it wouldn't make sense to say for toolbar item in nil, okay? So that makes no sense. So you can't. Here you better be darn sure that that array has what you want. But then inside, now toolbar item is a UI bar button item because I casted the whole array from array of any object to array of UI bar button item. Understand the difference there between those two? Okay. Another example of any object and where it appears. So if we hadn't changed, when we control drag to make append digit, what if we had left it any object? Okay, so we had append digit sender colon any object. How could we have dealt with that? Well, we just would have said, if we can let the sending button equal sender as a UI button, then do what we do. Let digit equal sending button dot current title, exclamation point, et cetera, et cetera, et cetera. Make sense? But we didn't want to put that extra if let, and I hadn't taught you about as, so that's why I said be sure to put that thing UI button. All right? Now you might ask, why is that even in any object? When I control dragged, why didn't it just put UI button? Why did it even offer any object? Well, because you could have an action that is sent by two different kinds of UI elements. Maybe it's sent by a button and also by a slider. I don't know. how that would be. I couldn't even think of an example of that, but you possibly could. It is theoretically possible. And in that case, the sender, any object, and you would have to say, if the sender is a slider, then do one thing. Else, if the sender is a button, then do something else. And you would do that with as. Okay?